I'm really glad to be doing this webinar for High Desert Food and Farm Alliance. And today I want to give you some tips on how to create bee habitat on small farms. And I really have three goals, but the three goals are going to take a little while to work through. By the time you're done today, I want you to be able to recognize bees on small farms, what they need and where they live. I want you to be able to create a bee plant inventory of your small farm, not your small, and a weed management approaches to promote plant communities that help bees. So in going through this today, feel free to ask questions as we go along. And I also have to say I'm a little bit under the weather. I'm just recovering from a bout of food poisoning. So if I start to lag, just give me a prod. Let's talk about the bees that you're going to be seeing and where they live, what they need. The formula is pretty simple. Here we have a little sweat bee on a Nooka rose petal, and she's telling you through her little mouth, all that I need is I need a place to make a nest. And from that point where I make my nest, I need to be able to get forage. In the same way, if you have livestock or anything like that, bees have forage, and they're all provided on this rose in the form of nectar and pollen. Over the course of their individual lifespan, and you're going to learn today that many of our bees are solitary. But in the case of other bees like bumblebees or some of the sweat bees and honeybees, over the lifespan of their colony. Now, I want to just quickly point out, this is very different from other kinds of pollinators. Butterflies, for example, they don't create a nest. It is if you take this butterfly, this is the pine white, this female will go from flower to flower, gathering nectar, but really her life cycle takes a different turn in that she needs a place to lay eggs for her larva, and her larvae are going to eat that host plant. And in the case of the pine white, it's pine needles. And I did want to quickly point out that we have a wonderful guide to the butterfly food plants of Oregon, Care of the Oregon Flora. In their second volume, in their appendix, they have a great list of the different butterfly genera. And you can see here, there's the butterfly species that we were just talking about, the pine white, and it shows you the plant genera that they lay their eggs on. It's a great resource. But to get into this issue of where bees are on your farm and your small farm and how to sort of enhance your habitat for them, let's start on thinking about their nesting substrate, where they're nesting. Now, we all know that honeybee colonies, they nest in these boxes. The boxes get moved around. That is really just one kind of nest, but it is an important one in Oregon. Our bees are just trucking back up from California as we speak. They're going to be going up into cherry pollination next. Some probably have already arrived, sweet cherry and Columbia River Gorge. But there's all sorts of seed production that require bees, as well as in Central Oregon, one of the biggest pollination events in the state is the pollination of carrot seed. And so if you have a small farm and you're growing any of these crops, these are, all of these can be pollinated by honeybees. They do a great job. The only exception to this, and I don't think this will fall in the small farms category, are alfalfa seed. Alfalfa seed is terribly pollinated by honeybees and typically require another bee species, either alfalfa. Well, in Central Oregon, it's always going to be alfalfa leaf-cutting bees, which can be purchased and used to pollinate alfalfa. But of course, in a hay crop, you don't need to set seed. And for all of these other crops, honeybees are a perfectly adequate way to pollinate these crops. But I want to point out that honeybees are just the tip of the iceberg, and many of these other bee species that we have in the state can be really excellent pollinators, especially when you're on a small farm and don't have, a big monoculture of flowers that need to be pollinated. These bees can do a lot of that work. I want to just point out that they really differ. Look at that bumblebee in the top right-hand corner. It's huge. And this is closely related to a bumblebee that you'll have on the east side, Morrison's bumblebee, all the way down to that bottom right-hand corner, a tiny little bee in the fairy bee in the genus Perdita. These are all bees. Some of them are red, some of them are green, some of them look like wasps. They're tricky. We have a lot of them. Now, I just want to take a quick detour. How do we know how many species we have? OSU Extension has this guide from 1969 that just looked at the bees in this area that's in white, which they consider the northwest of America. So you can see a little bit of Northern California into Idaho, a little bit of Montana, in that whole area. You can, I have a lot of QR codes in this presentation. You can download these resources for free. If you hold your camera up, hover it over that QR code, then you have to turn your camera on. You then press a little yellow thing will appear underneath the image, and that will take you to your website on your camera, and you can download these. But if you go into this publication, I kind of didn't set this up right. So we don't know how many, since 69, we hadn't had a real list of bees, but we do have, many of you might know, we have master gardeners and master naturalists. OSU also has a master melathopologist program where a bunch of bee nerds like these go across the state. A number of them are in Central Oregon, and they just go around combing for bees, trying to make a much more updated list of the bees of Oregon. And since 2018, when we started this endeavor, you can see each one of these dots is a different year. We've got really good coverage of the state, especially if you look in Central Oregon. Look at all those dots in Central Oregon. Each time a bee is collected, the plant is collected, the plant information is collected at the same time. So we have this rich network of bees and plants that I'll talk about a little bit later. But when we go back to this publication, there's an appendix in there that shows the bee genera of the state, and you can see them listed here. This is for the Northwest, is in the column there. Middle column is all of North America. You can see we have, it's some of these groups we have, these are, so you can, I went a little bit fast, but these are the genera of bees, the genus of bees. So Homo sapiens, Stelis is the equivalent. As you can see for here, there are 18 species of Stelis in the state, and there's 40 in North America. But this is an old account of this. And of the 3,500 bee species known in North America, this region that I showed you that was highlighted is pretty rich, almost a quarter, approaching a quarter of the species of North America are found in this region. When we line this up against what we've been finding in the Oregon Bee Atlas, we're noticing that some of these groups, we have more species than we thought. Some of them, not quite as many. Some we have not located since. But in total, when we take this list, and some of them never occurred here, they may have been in British Columbia, they may have been somewhere else. So when we line this up, we actually think we have about 782 of the species in the state. So 782 species, folks, that's what we're talking about. And that's probably intimidating to you. 782 is too much to remember. You want a little help. You have a lot to do. You run a small farm. You're not an entomologist. I'm going to help you break this down just so that you understand at least the minimal amount of natural history you need to get this job done. And this doesn't seem minimal. I immediately confront you with a complicated family tree of the bees. I just want to point out that the bees can be, one way to separate the bees up is into these these 6 families. And 4 of them, highlighted in blue, are called short-tongue bees. They have very simplified mouth parts. And 2, which include on the left-hand side, the Apidae, include the bumblebees, the honeybees, some of our carpenter bees, and the Megachilidae, which include all the bees that, like mason bees, alfalfa leaf-cutting bees, are considered the long-tongue bees. Now, that might not help you, but let me just give you another way of looking at this diversity that might give you a sense of how strange this is. The first thing is that most of you, when you think of bees, you think of honeybees, you think they're highly social, there's a queen. And when you break down this diversity, you'll notice that only less than 10% of the bee species are social. The vast majority of them are solitary. A single female is going to make a nest, and she never has nest mates. And when she's done creating that nest, she dies, and that's all there is. That's the most typical form of life cycle for bees. Most of them are solitary. The other thing that will be really remarkable to you that you may not have known about, and you can type in the chat if you did, is that even more common than social bees are brood parasites. Here's a picture from August Jackson's Bees of the Willamette Valley. You can see there's these 6 genera of bees. The Melecta, for example, are parasites on bees of the genus Anthophora. So these bees will, what I mean by parasite is all they do in their life, they emerge and they look for the nest of a bee from the genus Anthophora. They'll climb down the nest, they'll lay an egg, they'll take off. They don't make their own nests. Okay, this may still be esoteric, so let me break it down one more time that I think will be more relevant to you. How about if I tell you 70% of the bees make their nest somewhere in the ground? So all the ones that are not, that haven't been grayed out, these all nest in the ground somewhere. The typical life cycle is something like this. A female bee will come along. She'll find the suitable nesting substrate. She's looking for some kind of combination of clay, soil, silt, whatever. And then she will dig down. And then once she's dug this central chamber, she'll make these side arms where she will, in the evening, she'll structure it out. She'll then fly out, collect some pollen, put it into these little balls, lay an egg, and then that egg just eats that ball of pollen. After she's done this maybe 12, 20 times, she'll backfill that nest, and then she goes off and she dies. That's the typical, notice there's no honey here. All there is balls of pollen and a nest in the hole. And you will find these nests everywhere. So here's a technician in my lab, Sarah Taylor. She's at a bog, cranberry bog in Bandon, and right along this whole berm is just full of little holes of bees flying in and out. Sometimes the bees will form nests in single file, but here you can see an example. This is from Hoyt Arboretum in Portland. There's just a whole lot of bees nesting together side by side in aggregation. They're not social. Each one is an individual nest coming down into the ground. And they last, you'll see these little mounds for maybe 3 to 4 weeks, and then they're gone. The typical life cycle for these ground nesting bees is the bees will emerge sometime, starting now. You already have, as soon as the snow melts, you're going to have some of these bees starting to emerge. Some of them emerge in the summer, but we're taking a spring bee for an example. They emerge, they make the nest, and then they go through the development, and then for most of the rest of the year, they kind of hibernate at a stage just before they spin their cocoon and become an adult, the prepupal phase. And so they're kind of waiting until enough temperature comes, complete their development, and then they pop out. These nests, folks, can be, and I often get this question from people who are working on small farms when it comes in regards to tillage. Many of these nests are quite a few inches down. So this is a graph of the maximum and minimum reported depth of these nests for 445 species in the West. And you'll see, most of them, there's a big bulk of them around 5 inches to 10 inches down. So they're fairly deep, and some of these are going 30 inches into the ground. They're going quite deep. Now, I think maybe before I go on, I'll just see if there's any questions before I'm going to go into bumblebees in a second. And I do promise we're going to get into some practical brass tacks methods in a second, but are there any questions? All right, I'm going to keep going then. There'll be an opportunity. I'll have a little question break in a second as well. Bumblebees are particularly well. We have a lot of bumblebees in the state of Oregon, about 25 species. They are social, unlike these other bees, and by and large nest in the ground. What you'll start to see are these big queens. As soon as it's a warm day, these queens will then make a nest, and it will pop these workers that often look identical to them, but they're much smaller. They are, of all these bees, some of the best pollinators in any of these crops. For example, we have a couple of large-scale agricultural systems in Oregon, clover seed production, and the other one being Oregon cranberries, where even though they rent honeybee colonies, you can still see a third of the bees in those bogs are bumblebees that are pollinating. And as you can see in this graph, different species come in different proportions. In Bandon, which is very different bumblebee fauna than you have in Central Oregon, the majority of the bumblebees are these yellow-faced bumblebees, but also other species in smaller proportions. The life cycle of bumblebees starts with what you're going to see in a couple weeks are these bumblebees are going to be emerging from some place where they're spending the winter as mated females. They don't have the mouth parts of these other ground nesting bees. They really need something. They can't dig very well. So oftentimes you can imagine you've got a little bit of a forested edge on your small farm. There's pine needles. The pine needles fall and make a duff layer. That's typically where they'll spend the winter. And oftentimes when they find a really good spot, you can have multiple of these mated queens just under there waiting. Also, another place you might encounter them on your small farms is if you have a sawdust pile. In a sawdust pile, you often will be working through the sawdust pile and come up across a bunch of queens that are just there, and they're very docile and dormant at that point. But out they fly. What you'll next notice is this kind of behavior. This is they're going to find the next thing they're going to do is they're going to find a nest, find a place to make their nest. They can't excavate their own nest, so they're looking for a pre-existing cavity, often rodent burrows. And so when they're looking for the nests, you'll know they're looking for the nests. You'll be out working, and you'll notice these bumblebees flying close to the ground like this. They're just kind of hovering around. This is called questing behavior. What they're doing is they're looking around for a good nest site. You'll often see them. They'll find a little hole to crawl in. They'll crawl back out if it's not suitable. But this happens early in their lives, and after that, the nest is established. Now, sometimes I will point out there are some bees. There's a couple of genera, like the black-tailed bumblebee shown here, that will nest above ground. Most of them won't. And this is in Bandon. We made these little nest boxes on the edges of the bogs, and you can see they just poop all over the front. But we have a little bit of upholstery cotton inside, and they just, but most of the bees won't nest above ground. They need to nest below ground. So there they go. They start the nest. The nest grows. And as the nest grows, you know when the nests have been established because all of a sudden there's smaller bees. You saw these huge bees before, but then these smaller bees start to appear all over the flowers. That's when you know the nest has been established. And then as the colony grows, they start to make reproductives, new queens, new males. They mate. The colony actually collapses. It dies at the end of the year, and what you're left with are these mated females that nest again. That are, sorry, not nest, but that are spending the winter in some kind of duff layer. In contrast, 30% of our bees don't do anything in the ground. They nest. They're cavity nesters. They nest usually an abandoned beetle burrow or some kind of a plant that has a hollow stem. That's where they nest, and you can see them in color here. The most common one, the one that most people know about, is the orchard mason bee. Here you can see the female. She's mining for mud. She's going to take it back to a cavity, in this case a twig. She'll line the twig with the mud, and then she will collect the pollen, lay an egg, close that off, make more of these cells. There they go. And you can actually buy these, cocoons to start the nests from suppliers. And after so you can buy these cocoons. They're about $1 to 50 cents a piece, and they are great pollinators of anything in the rose family. You don't need twigs, though. You can make your own blocks for them to nest in. Any wood that has a 5/16 router hole through it, and it should be at least 9 inches in depth, they will nest into. We do have a card at OSU Extension on some of the steps to managing mason bees. It's not, if you're going to manage them for pollinating, I don't know if anybody out there is doing cider apples or anything. They're really good pollinators for small fruit production. But it does require some amount of management, cleaning the cocoons in the fall, wintering them. And I will point out, although this is on the other side of the Cascades, OSU Extension has bee notes. This is put up by the Linn County Master Gardeners. It's really excellent in knowing the timing to deploy cocoons, when you should be cleaning things up. You get a regular email blast from Linn County Master Gardeners. So, well worth checking out. The only other thing I wanted to point out before I go to questions again is we also have a number of bees that like pithy stems. This is one example, the small carpenter bee in the genus Ceratina. We have about 5 species in the state, but they really love, some plants that you may put on your small farm for bees are also nesting habitats. So spirea is a great example of this. Has a pithy stem that these bees love, and you'll see them. If you look at old growth on a spirea bush and you see a little hole in it, you can sort of peel it back. You oftentimes will see the developing larvae of these bees inside the stems. All right, that brings me to another bout of questions, if there are any. So I'm kind of curious, maybe you can put it in the chat. How many of you are interested in bees simply because you'd like some pollination, or how many of you are just conservation minded? What's your kind? Just if you have you can just type in the chat. Let me know what your interests are. So pollination or just conservation, or you could also type in the chat pollination plus conservation, and then I know a little bit more. Maybe you go both ways on that. Okay, thanks, Lauren. Pollination and conservation, great. Hey, Sierra, nice to see you out there. Great, pollination and conservation. I'm going to take it from the sample size of 2 that you have both interests. So I will keep that in mind as we go through. And I'm glad that there's interest in conservation as well. I think, especially where you are in Central Oregon, you really are sitting on one of the richest areas of bee biodiversity out there. Hey, Sierra, you raised your hand. Yay.
Yeah, I have a question for you.
Okay.
You mentioned earlier, and maybe you'll get to this later in the session, but just about, how far some of the bees burrow, those that are ground nesting. And then you mentioned how it relates to tillage. And I was just curious, I don't know if you're going to get into that later, but just whether there are ways of avoiding disrupting some of those ground nesting bees.
That's great. No, it's good. And Sierra, you're in Central Oregon? I've never.
I'm not today, no, but
Okay.
I do travel around the state, so.
Well, I know you do. Okay, that's great. So I would say the issue is it's hard to say because tillage is really important. And I think that the key thing is, and I think this has been shown out in a lot of studies, is having some area that's not tilled. So whenever people have done studies on bee biodiversity on farms, oftentimes what's strongly related with the number of wild bees that are on the farm is the percentage of land that's not under tillage. And clearly you have all sorts of land that's not being currently tilled. I think where this sometimes it has come up, has been more pronounced is for people who are pollinating squashes, cucurbits. there is a bee, as you know, Sierra, that's coming up from Southern Oregon. It's starting to expand. It has not reached Central Oregon. It's a native of California, but for some reason it took a long time for it to ever get here. It is a great pollinator of squashes and gourds, and if you had a system like that, every time you till, because they do nest really close to the gourds and the squashes, you may start to take them out, and that might hit your pollination. And I don't know a good way to do that if you're trying to do weed control at the same time.
Thank you.
Yeah, great question. Okay, William wrote small fruits, apples, pears, plums, and cherries. Great. Oh, Jimmy.
Yes, I was wondering about the cranberries you were saying in Oregon.
Yeah.
Are bumblebees the main pollinators for those?
Main pollinators are still honeybees.
Right.
But I think on some of the smaller bogs, they may not need them, to be honest. I think they have enough bumblebees that are present that they could probably scale back their honeybee orders.
And so, I know that there's like been an increase of management of like the mason bee and a lot of increased management of like the orchard bee and stuff like that. Is there that same kind of increase of management of bumblebees, or is it harder to manage them?
That's a great question. Bumblebees they're really hard to work to get nests established.
That's what I was
And there
saying.
are companies that produce them, but they're very industrialized and very kind of carefully managed. It's like greenhouse level. So there's a company in California that makes that yellow-faced bumblebee. They kind of create the nests in the lab and then get them up to size, and then they transport them out. They're fairly pricey. But I will say with the mason bees, they are easy to manage. And for people in Central Oregon, I would just be a little bit wary with the supply. We have an invasive bee in the Willamette Valley right now, the Japanese horn-faced bee, which may be in the cocoon supply. So just be a little bit careful while you're getting them and getting the cocoons. Just ask them, are you clean of these bees? We don't want to introduce them to Central Oregon. And I will say, to William's point with small fruits, they're really an affordable way to do pollination. And the nice thing is you own them, so you don't have to deal with a beekeeper. You've got your own bees there. You can manage them, clean them out, continue propagating them.
Cool, thank you.
Yeah. Hey, Sierra.
Hey, I have one more question. I'm curious, just because of the flooding that's been happening across California. I know February is typically the time when honeybees are pollinating, some of the, nut trees like almonds down in California. And I'm just curious whether this year is really unique, whether had any impact on honeybee movements, California, and then, populations up to the Northwest, and just any of the impacts that you're aware of.
I have heard that it was a pretty cold, wet year. People didn't have that much trouble getting in. There were some areas of California that they did have a hard time getting their colonies in because it was just too wet. But I think the bigger thing is that it was a difficult winter for Oregon beekeepers this year, and they went down to California hoping they would get a flush of pollen and nectar for their colonies to grow on. And I think it didn't work out really great. So they may be struggling when they come back to Oregon. But who knows? Everything here is stalled on our side. I don't know how it is over there, but for us, blueberries are still waiting. So
I took bees down to California. I'm a beekeeper in Central Oregon.
oh, how'd it go?
It was really wet and really nasty. But I mean, there was still a bloom, but definitely the growers are gonna the price of the almonds are gonna be are gonna be expensive next year. I'm not very good.
Yeah.
We were getting stuck, but we were getting all our bees together. We were getting people unstuck from getting people unstuck from getting people unstuck. So it was, it was pretty nightmarish. But In general, the honeybees did great. It's such a big bloom that
Okay. Oh, good to hear.
overall, I mean, they did great. I mean, it's always going to be good. The bees do really well as far as the pollination. That's a different story.
Thanks, Jimmy. I'm glad to get that update. That's good. Okay, let me move on now. I did want to also, maybe this is the point that Jimmy was bringing up, that in almonds, there was enough pollen and nectar that came through. And this is really the key part. The other part of the formula for bees is that they do need to have forage available to them, the form of nectar and pollen over their individual or colonial lifespans. And if we look at this brassica flower, this mustard flower, when we peel back one of the petals, you can see the two resources the bees are going after. The first one is the nectar, which comes from nectaries, typically at the base of the flower. The bees use their long tongues to extract that nectar. And then on the way out, they rub up against the anthers and pick up the pollen. Now, some pollinators like butterflies and moths, they just do this incidentally, but bees are tremendous pollinators because they're actually harvesting the pollen. And in the process, they're really moving pollen around. Pollen will land on the stigma. From there, a little pollen tube is going to tunnel its way down to the ovaries, which in the case here will give you a nice seed set on this flower. So here you can see one of those honeybees carrying that pollen. She has special organs on her back legs. You almost always know it's a bee if you see pollen like on big parts of their body. She comes back to the nest and she'll pack it into the same cells that her larvae are living in. So you can see in the middle, the brown area is the kind of the little brown domes. That's what the developing pupa are. Having that pollen is what allows the colony to grow. And I just want to point out, when we're talking about forage, not all plants are like that brassica flower. Some are pollen only. So all of the poppies, for example, do not provide nectar, only pollen. Same goes for the lupins. There's only pollen coming out of lupins. And thinking about those two plants, poppies and lupin, I think about Ian Silvernail at the Plant Material Center here in Corvallis, who points out that when you do seed mixes, and he's got a great seed mix that he's been working on for the west of the Cascades behind him, you really need to be mindful if you want to have a diverse floral blend, not to go too heavy on those two plants. So you can see here, they say, watch out for species that may dominate a mix, and the biennial lupins and also California poppies should always be less than 10% of a mix by weight. You can download this good pollinator seed mix for the west side. There's some good plant ideas in there, but I like the principles. You got to be very mindful when you're planting to have a good blend of annuals, short-lived perennials, long-lived perennials, which is all covered in this book. But I want to get back to this nectar and pollen question, and also the reason why you can't just use one plant for all the bees. And so a great way to illustrate this is in the West. You have this up in the East as well, where you'll have, as an ornamental arrangement, black-eyed Susans growing right beside Russian sage. And if you get in close, you'll notice that the bees on these plants are completely different. If you go to the black-eyed Susans, you'll see here we've got a sunflower bee, sweat bee, and a small carpenter bee on the left. When you go to the right, it's honeybees, bumblebees, and a leafcutter bee. They partition themselves amongst flowers continually. And so if you want to know one of the key reasons they do this, it's tongue length. Remember, I told you earlier, there's long tongue and short tongue bees. Well, the tongue length is really important to having different shaped flowers is important to attracting the range of bees. So if you take this is the California bumblebee. She's on a current. In a couple weeks, we'll probably see this. And there's bees all over the place. I have colonies just down the row from here, and you don't see any honeybees on this. You don't see any other bees on this because no other bee has the tongue length of this bumblebee to get to the bottom of those flowers and pull out the nectar out of those current flowers. But I want to point out that it's more than just this, that, the tongue length is important, but it also, bees are interacting with one another. To get at this, I'm sure you've all seen this in Eastern Oregon. You'll have oregano and lavender growing side by side, great summer plants, don't use a lot of moisture, really good bee plants. But if you grow them side by side like this, you'll see that honeybees are almost entirely on the oregano. And on the lavender, there's some honeybees, but it's predominantly bumblebees. Now, the question arises, honeybees do like the lavender. Would they be there in larger numbers if there weren't any bumblebees? Is there competition going on? Somebody in the UK had this question, had this very elegant design. So here you can see 5 consecutive days, and the red is the bumblebees and the blue are the honeybees. And you can see, this is what you normally see. You've got the time of day there, and you can see on 5 consecutive days, lots of bumblebee visits, but not many honeybee visits. So what he did is he hired on an undergraduate to get a cane and knock away bees of either genera. So if you only exclude the honeybees, the bumblebee counts actually go up higher. But if you whack away the bumblebees, it's almost all honeybees. So there's competition between bees on flower. When you look at bees on flower and which species are there, it's complicated. There's the tongue length. There's also competition that's determining who's on what flower. But I wanted to bring you, especially since you're in Central Oregon, to this key concept, pollen specialization. So that's the other way. I've told you one reason you'll see different bees on different plants is the length of the tongue to get the nectar. The other big thing is pollen specialization. There are bees like honeybees and bumblebees whose larvae can digest pollen from a wide array of plants. We call them polylectic. But we also have, especially in Eastern Oregon, bees that have narrower diets. Oligolectic bees, they'll only collect and digest pollen from one family of plants, or monolectic from one genus of plant. Now, there's some great bee plants out there that don't have any specialists. Ceanothus, any of the ceanothus are wonderful bee shrubs. I would include them in any planting that you would do. But there are no specialist bees on there. There's just a wide range of bees that just mob this shrub when it comes into bloom in the spring. But if you go to something like rabbit brush, as I'll talk about later, you'll find all sorts of specialist bees like these bees in the genus Melathopoulos that only go to composites. Similarly, on cactuses or mallows, you'll find diadasia, and only there. And sometimes you have these real tight connections. So Coleopsis will only be found on Cleome, the Rocky Mountain bee plants. If you don't have this growing, you'll never see these bees. And here's another example of a Diphorium mora that you only find on Campanula. Without those plants there, you won't see them. So let me just give you a rundown of some plants in Central Oregon that you'll have a high level specialization with. And to get at this, these are the master melittologists, and they're holding a network of the state. On the top are the bees, and each one of those lines connects to a plant on the bottom. It's a dizzying array of plants and bees that they've created. But this has allowed us to see where there's really tight associations between some bees and some plants. I'll talk a little bit later about how you can use this on your small farm to sort of make plant selections. So one thing that's going to be coming into bloom here pretty quick are the willows. We have a number of specialists on willows. In addition, honeybees will, great honeybee plant as well. It's a great source of pollen right across the board. But when it comes to specialist bees that really, you won't see them, willows are one of those plants. Also, wax currant's another one. We have a number of specialists that you only find associated with wax currant. And such an easy to grow native plant for the east side. Any of the plants in the genus Phacelia are super plants for, there's all sorts of weird and strange bees that are on the Phacelias in Eastern Oregon. And they're not showy plants. if you go to Oregon Flora's website, you can pull down these maps. You can see these are all, each one of these little vignettes is a species of Phacelia. And you can see there's a whole bunch of them. Some are east side, some are west side. Some of these you can get from, seeds readily from nurseries, but it's a great plant. I also mentioned rabbit brush. We have a number of specialists like these small fairy bees that you see just crawling all over these when they come into bloom in late August, September. The mallows are also a remarkable source of bee diversity, and we have a number on the east side. I hate to say this, but some of these are terrible plants for your farm. So the thistles, we have native thistles, folks, but there's a lot of specialists on thistles. And if you're able to get some native thistles propagated, they're hard to start. They're hard to get seed material for, but they're great. And then anything in the legume family will have a number of specialists. So, the astragalus pictured here, but also any of the exotic plants. So if you're growing, sweet clover or alfalfa or any of the other clovers, those are exotic plants, but you'll find specialist native bees in Oregon going to them. Our sages are amazing bee plants. There's all sorts of specialists on the sages. Again, here's some, you can just see in Central Oregon where we found bees in the past. These are all our sage observation. You can see there's tons of bees that we find, strange bees that we find right in Central Oregon. The dahlias, the wild dahlias, also a source of really great bees. Here you can see some of our observations, again, in Central Oregon with the dahlias, tons of them. So those are some great bee plants, but I also want to just give you some other tips, because for some of you, bringing a weird and wild assortment of bees to your farm may not be your focus. You may be looking at, trying to get bees to pollinate your crops or other objectives. So here's some tips I wanted to give to you. Make sure you have flowering that overlaps. So here we have Kim Patent, who's retired from Washington State University in Long Beach. He has one goal in mind. He wants to get bumblebees onto his cranberry bog, and he wants those, he doesn't want the flowers to be competition with the cranberry when it comes into bloom. And then when the cranberry is done, he wants those bumblebees to have high reproductive success so that they nest around the bog the next year. So what he's done, he just did this cheap nursery stock. Bumblebees love heathers. So he went through all the nursery material and found a variety of heather that blooms in the spring before the cranberry bogs are there, attracting the bumblebees to nest around the bog. And then these species come out of bloom just as the cranberry comes into bloom. So the bumblebees then turn their attention to the bog. And then as the bog comes out of bloom, he has a summer heather that comes on to bloom. So the bumblebees are just skipping from one bloom to another, very carefully put together. And that's a great strategy to ensure good success for your bees. The other thing is to include natives, not just exotic plants. As I just told you, some exotic plants are really great for native bees. There's not a real good, rubric for this, but I will point out that in some cases, exotic species may have a lot of bees on them, but those bees are generally not wild bees. So you can see in this graph here, this is from the west side, the very top plant here is oregano. Oregano just hums with bees, and you can see lavender is not that far behind it. But in this case, you can see the yellow is the honeybees. And you can see there's a lot of honeybees on those plants. So great honeybee plants, if you're trying to create forage for honeybees, which is really important in Central Oregon, just to have some nectar and pollen for honeybees, they're great. But if you wanted to get more diversity, you might go to the fourth plant in this list, the California poppy, that has a lot of other bees that are visiting it. And then just coming back to lavender, which I think is such a great plant for just water-wise and not using a lot of moisture. I think this is over Milton Freewater at one of the wine growing areas. Shrubs and trees. Don't forget shrubs and trees. You should put most of your investment into shrubs and trees. Once established, they won't use much water. They have so much bloom per meter square, and they're the biggest bang you can have for your buck. And I just want to draw your attention before we go to questions that we have this great Shrubs and Trees for Bees publication that just came out. You can see this mining bee on another great bee plant, snowberry, but you can download this. It has range maps that'll show you the shrubs and trees in your region. It's really great. Okay, how are we doing for time here? Okay, any questions? Let me move on then. This will maybe pull it all together. This is what I really wanted to talk about today. I wanted you to create a plant inventory for your small farm, I apologize. And because I think it is the kind of backbone of an approach to working on attracting bees. You'll often think, well, I got to plow something up. I got to lay down some seed mix. No, that's not the way to go. You already have great plants growing on your property that you should leverage. I turned to Mark Wannock, who is a retired equivalent of NRCS in Canada, the Natural Resource Conservation Service. And he always had this rule of thumb. He said, protect what you have and add what you can. So really taking an inventory of what you already have on the farm and then just adding in the gaps that exist. Now, the translation of this rule of thumb into practice is something that we started to do with vineyards out in the Willamette Valley, where we had each of the vineyards create an iNaturalist project and then had them go through their property, taking pictures with this smartphone app to document the plant diversity. So you can see here, Soder Vineyard, they've got a total of 33 species of plants in their first year of doing this. And then, so they're plants. We don't know what those plants are, whether they're good for bees. We just know they're plants. And what they've done is, and I'll show you how to do this shortly, is they've created a little map around their property, which harvests all the plant data that comes in from that property and allows them to get a total plant list. The next thing we do is we run that plant list against the bee atlas records. So I already showed you that big, long network of bees and plants. Some of these plants are going to be terrible. The Queen Anne's lace, not that great for bees. If we line them up against the bees, the bee records, we get something like this. So they do this, we can download their records and we put it into a script that looks at the plants that they have and predicts the bees that they have. So it says the 20 most important plants on their property are shown in Figure 2. These plants should be protected in order to maintain wild bee populations and could also be planted in other areas. And it says there's some here, like Iberis and Vinca, that have no recorded bee visitors and are not useful. So there's some plants that are just not that useful. So it goes through and it just shows them weighted by the species, like Salix, which I've already told you, willow. Willow, we've got a lot of diversity of willow, and you have willow has a lot of diversity in this bee genus Adrena, which is the mining bees. And so when you have it, you automatically are going to get your high likelihood of getting bees of that genus. And so some of these have very weak associations, so you may not see them as close, but it gives you a sense of what you have. And what we can translate this into next is a recommendation. So based on this farm, we've noticed that if they had these 3 genus of plants, they would increase their bee diversity by 5. And these are the species that are likely to happen, likely to bring in. And it gives them a great sense of like what they need to plant based on what they have. So how would you do this? The first step you need to do is get the app iNaturalist. You can download it on your phone. You'll have to create an account. Once you have that, then you can just, anytime you're out working and you notice a new plant, you just take a picture of the whole flower. You take a picture under the flower for a lot of composites we need to see under the flower, and take a picture of the whole plant. Got those 3 images now. When you go into iNaturalist, it'll then ask you, do you want the computer algorithm to guess what the flower is? It'll give you some suggestions. And then if you know roughly what it is, you think, I know this is a balsam root, but I don't know which one. You can select that and it'll populate it. The next thing you got to do is you need to create a property map. And the easiest way to do this is to go get Google Earth. And in Google Earth, you can easily go through, use this tool right here, this little polygon tool, and it'll allow you to draw a rough boundary edge on your property. Then you go to that property, that new shape that you created, you export it as a KML file. And then that'll come out and you'll actually load that up into iNaturalist. So you go back into iNaturalist and you create a new project. So here you see I've created a project called Soder Vineyard Plants and Pollinators. And there's a step before this I forgot to tell you. You need to take that that KML file in iNaturalist. You're allowed to create new place names. So you're going to say small farm in, Prineville. That'll be your new place name. And then from here, you can see what we've done is I then create a project in iNaturalist. So there's 2 things. There's the project, but also there is the place name. So you create a new place name of your farm. Then you go into iNaturalist, you create a new project. You can upload logos so that if you wanted to make it public facing, anybody could see this and they could see how your plant diversity is. You include your name. So when you create the place, your farm name, Oregon, USA, you'll just type here include. Since you've created that place, it'll create an iNaturalist project for your property. And what I do here is I set this up to include only plants and bees. You could include it to include all sorts of, if you're interested in frogs, butterflies, you could make this much broader. But for the purposes of us, we're looking just for the plants and the bees. And then the next step is that iNaturalist, just as soon as you got that all set up, iNaturalist will just, anytime you or a worker, or if you've got a farm stand, a visitor visiting your farm, takes an image, it'll aggregate up and you'll get this, automatically over time, you'll create this real robust species list for your small farm. And then the last step is, once you've done this, you can go to export observations and it'll export a spreadsheet that will come to me and I will generate the report back to you, matching your records up against the against what we have in the Bee Atlas. It's the only place in the world you can do this. Oregon has really done a great job with getting the bee plant data connected. And so that really, I think it's an incredible tool. And I think over time we'll be able to increasingly make it more useful, but that's what we got so far. You're going to need to go through, watch the recording to try this, and you can email me at any time if you run into any glitches. And Andrea and I talked about potentially for the fall having a second webinar where anybody who went through and did this, we could go through each of your farms and just talk about which plants are missing, strategies for putting them in place, trying to think about what the next steps of doing this are. But before we do that, are there any questions? Sorry, we're going to do that maybe do that in the fall, but are there any questions that you have? Yeah, Sierra.
Yeah, my question is just on the back end. Let's say someone were to, get the data and then download that report. Do they then send you the Excel sheet, or is it automatically sent to you? Like, what does that process look like from taking that data and then you creating whatever that plan is that you had?
Yeah, right now we're still in the early stages. So you have a CSV file that comes out. So which is kind of like, for those of you who don't know, it's kind of like an Excel file. Just attach that to an email and then send it to me. Yeah, but hopefully in the future we can automate it a lot more. Lauren.
Hey, I've learned so much. Thanks so much for having this course. I would just kind of like a synopsis of, because I didn't realize that there were like flowers that were for bees that were not honeybees and different varieties. Like, is it ideal to have a diversified type of bee on your farm, or is it better to have, is it better to just attract honeybees?
I'll just be blunt with this. I think honeybees are really good at pollinating most plants, and
Okay.
generally pretty available too. So if it's just a pollination issue, but I would say on small farms, you may be able to build up wild pollinator populations. But wild pollinator populations will go up and down. Honeybees go up and down too, but you can still bring them in. So when it comes to like a crop pollination situation, what's yeah, tell me a little bit about your farm.
We have a lot of diversified plants because we do vegetables and flowers.
So but you don't need pollination of those, do you? Oh,
I
vegetables you
mean,
do. Yeah.
we do all the vegetables, every single one of them, besides soy.
Yeah, it might be the case that just yeah, I would still say that honeybees are kind of your go-to. If you can, have you had trouble getting availability of honeybees?
Oh no, actually, Jimmy on this call partners with us, and he's going to bring some bees over to our farm. I just want to make sure that we're set up for success because we do have a lot of flowers. Like the second question I was going to ask is is it ideal to have the best flowers or shrubs like together so that the ones that aren't like so that there's no so they're not fighting over the other, like or competition like you were talking about with the oregano and the lavender. Like is it good to like group those specific ones that attract bumblebees together?
So what I would say with that is, oh well, like so you're saying if you've got like crops, you've got so many crops side by side, and it's like should I the way that I arrange my rows, should I try to keep? I would say it doesn't matter. That bees will
Okay.
find the most attractive. But if you have coincidental bloom, like one thing that can happen is you could have alfalfa blooming right beside your property, and your bees are going to go to the alfalfa.
Mhm.
And some of those
Yeah,
you just
there's a
have
hay
no,
field near us.
yeah, it's just like they really love it. So some of that you don't have a lot of control over. And some of this with augmentation, you may want to be like Kim was thinking. He really wants to make sure they don't like cranberry that much. He wants to make sure those bees are focused on the cranberry. So he doesn't want any competing bloom at that time. So, but at the same time, as Jimmy might tell you, it's really hard to keep bees in Central Oregon in August. There's just not a lot blooming. And so if there's stuff that you can put in the landscape to help the bees later in the year, that's the time that's really hard. Bee colonies do really well if they've got a good pollen and nectar flow towards the end of the year.
Okay.
So try to think a little bit about what wouldn't compete. What is there anything that you think is difficult to pollinate that you have?
Uh, Not really. Jimmy's bees were here last year too.
Okay.
So, but I just want to make sure, just learning that there's competitive plants, is it ideal to separate those out? But what he's explained to me too is that they pollinate a very far distance, so there's a lot.
Yeah, they're not, if you, yeah, they're going to go far distance. You don't have to worry about that. And they will find the plants. But if you have something that's hyper attractive, it can pull bees off of something else.
Mm-hmm. Okay.
Yeah. And yeah, for some of these things, just having, and some plants just be honeybees, tomatoes, for example, is just, they won't pollinate it. So you need bumblebees or something else that will sonicate the anthers. So in some cases, there's some plants that really, eggplants and tomatoes, honeybees just won't do it. And so
Mm-hmm.
there's certain plants that you sort of do need coming back to your original question, having some diverse bees can sometimes just plug gaps. And in a diversified farm like yours, some of these wild bees might actually be contributing a lot more because of, honeybees like really will go to one thing. And it's hard to know without kind of digging in deeper.
Yeah. Okay. No, that's great. Thank you so much.
Yeah. Okay, let me take us to the end here. I did want to talk a little bit about weed management. And if you have this idea that you're going to try and protect what you have and add what you can, that really is focused on weed management. And so I would say the key steps that you want, if you've gone through your property and you've noticed you've got some good bee plants, it's surrounded by weed pressure, got cheatgrass or something. So the first thing is, don't broadcast herbicide where you've got a good density of these good bee plants. You only use broadcast herbicide to deal with weed problems where you don't have a lot of these bee plants present. If you have a lot of these bee plants present, then what you might want to do is use herbicides that target grass. None of the grasses are going to be for the bees. So it's real easy to control, use something like Post or something and just get that grass gone and allow those, with that competition out of the way, a lot of those bee plants will start to come in. The other thing is, you've got to go in, you've got some broadleaf plants and you've got to control them with a herbicide, and you don't want it to hit your, the plants of high value, then spot spray or mow. I know one person I know has actually put like a little, barriers over some of these top plants when they go through and they do their spraying. The last thing is, and I know this probably, you could never do this in Central Oregon ever, but nevertheless, you can use other methods. You got to get that thatch gone. Oftentimes, as soon as you remove that thatch layer, a lot of plants that are being suppressed by the grass come free. So really, especially if you remove thatch and then, maybe put some plugs into it, that might be one way of kind of getting some establishment of things that are already there, but are just being smothered out. Okay, I did want to talk a little bit about herbicide selectivity. We have been doing some research at OSU with some of the kind of common annual and perennial wildflower plants that are used in conservation work. Marcelo Moretti is our weed scientist. He's been, as you can see here, he's got patches with green and patches with nothing growing. What he's done is he's laid down pre-emergent herbicide and then seeded his plants straight into it and looked for what grows. And what you see here is that along the y-axis, we've got vetch, poppy, phacelia, gilia, clarkia, lobularia, and then he's got pre-emergent herbicides on the way down. And so you can see in the untreated plot, everything grows. But when you go down and you look at some of these pre-emergents, they can do a pretty good job of controlling other weeds, and some of these plants will come through strong. Remember, this is seeded at the same time as treated with the herbicide, so it really gives you a sense. We're going to have an extension publication coming out soon, just to show you how you can use herbicides intelligently to get some of these plots established. I also want to highly recommend this book. It's really wonderful. It's Weed Control in Natural Areas of the Western United States. It has some great tables. It goes through each of the weed problems. It goes through each of the strategies for doing management. It lays things out really well. It gives you a sense of how to clean problems up. And this is going to, you can see them. They're all laid out there. It's got like a spraying it. It's got, grazing. It's got tillage. It kind of lays everything out with all the major weeds in the West. So excellent book. It's a really good resource because weed management is at the keystone of trying to create good bee habitat. So let me just transition now and conclude with just two quick case studies. I'm sure each of you is going to have some great success stories to tell me, and I can include in the slideshow, which is, as you can see, still under development. But this case studies that protect what you can and add, protect what you have and add what you can. On the add what you can end of things, I really love this example by Jed Arnold. He was working for Hampton Lumber. His boss saw some kind of TED talk about pollinators and how they're in trouble, and so he gave him a bunch of money and said, after we do our logging, can you go in and create bee habitat? And Jed knew this was going to be a bad idea. So he got that seed that he's holding is probably a few $1,000s a seed. And he went and broadcast it into the cut block, and lo and behold, nothing came up. there's just too much competition. Look at all the thatch and, just the stems. It wasn't going to work. And so Jed then didn't listen to his boss. He saw that he had some slash piles. He knew each year the invasive weeds go into the slash pile. So he said, what if I seeded only in the slash piles? I'll wait till they cool. I'll seed directly into them. And lo and behold, he created some of the best bee habitat I have ever seen in my life. And what was really great, emergence was great. It came up real quick. And in addition, it started to spill out of the cut block in, it would seed, reseed, and move into the cut block. It was a brilliant approach to doing this. The other example I did want to highlight was just the intelligent use of weed fabric. This is George Kaufman at AgriCare. Runs a large, AgriCare manages a lot of blueberry acres in the Willamette Valley. And they know how to control weed and integrate plants. They know how to grow plants. And so they just use the same system they were using for their blueberries. They just put the pollinator hedgerow right in a line. They use the same weed fabric, same irrigation system. So that was just really integrated with the farm. And what I really loved was just how all the pieces of the management worked in with their farm. So I have this podcast called PolliNation. And in the podcast, he said, we prune the pollinator hedgerow in sections. Not only does this manage shrub size, but it extends the bloom time. How does it extend the bloom time? Well, he says the prune sections can bloom 2 weeks later than the unpruned section. This ensures we have plenty of pollen and nectar across the season for bees and other beneficial insects. You see what he's doing? By pruning only half of the plants, he ends up getting the same plant to bloom twice as long because the prunes part comes up just a little bit later. So just these kinds of observations, this kind of people like yourselves who are working on a small farm have to be a jack of all trades. You'll come up with some great solutions. And I'm looking forward to hearing about them. But just to conclude, I wanted to give you a couple resources. We do have this garden-focused publication, Enhancing Urban and Suburban Landscapes to Protect Pollinators. We do have plant lists in it for Eastern Oregon. And so some of these plant lists may be useful to you. It looks like this, and it'll lay out like dry, moist sites, full sun, and give you a sense of the color of the plants. We also have this program, which we're really doing in the Willamette Valley this year, but maybe that's something you'd be interested in the future, Bee Stewards program. We go into some of this information in more detail. We have done it this year where we have a lot of farm visits where we're going and visiting a bunch of places and getting a look at them. And maybe if we had enough people in Central Oregon, we could pull this off next year. And at the end of the day, you get this nice little farm sign as well. That's all I got for you today. We did go, I think we're still on time. We have a little bit of time for questions, but I know it was also a lot. But
Hi, I just have one more question since we were talking about how your friend had dropped $100 per seed for his pollinator seed. Is there any recommendations, because like Lacey Facilia is so expensive that like people just want to like sell it cheaper or donate it or, to small farms? Like any recommendations on getting more affordable pollinator seed? Why is Lacey Facilia is like the most expensive seed?
It reseeds really good, and it's a good cover crop, but you're right. And I would say that, like some ways NRCS obviously has some great programs. And I have heard that their payouts on hedgerows, on shrubs is very good.
Oh, cool.
Yeah, and I do think that, that the Facilia, you'll plant it 1 year and then it'll reseed a little bit, but you'll lose it in 2-3 years. It's a lot of work to put in. But, as a cover crop, but so I would approach NRCS and tell them I want to put a pollinator hedgerow in, and I can't remember what they're paying out on pollinator hedgerows, but it's a good chunk of they'll put a large part of the costs in there.
Cool. Awesome. Thank you.
That'd be the one thing I would suggest. But the other thing is when it comes to cover crops that bloom, there are all sorts of other things that are like, I think I've mentioned, like anything in the legume family is good for honeybees and good for a lot of native bees. So like vetch is great and cheap.
Yeah.
Or you know what another great plant is? I don't know how well it grows out there, but it's really loved by honeybees and a lot of great wild bees is trefoil.
Trefoil.
Yeah.
Okay.
Trefoil is another nitrogen fixing perennial legume. It's super cheap. There's another one that I really love for honeybees. It's called, and it's also, a lot of these legumes are so cheap. But it's a beast of a plant. It's called Hubam clover. It's like a sweet clover, but it's an annual, and it is she's big. Big,
Yeah.
big. Alfalfa also dirt cheap. You know, and the nice thing with a lot of legumes is they're deep rooted. Some of them are deep rooted, don't require a lot of moisture, and then you can mow them to sort of get your bloom to happen when you want them.
Right. Okay.
Yeah.
Cool.
But yeah, Phacelia, and Lacy Phacelia is the cheapest of them. You can go to the other, there's availability for things like, you know, Phacelia heterophila, which are even more expensive.
Yeah. All right. Awesome. Thank you.
Yeah.
I'm curious if anybody has done any kind of inventory of the kinds of pollinator plants that they have on their property, or if that's something that they'd be interested in doing, because I'd love to help support and connect folks to Andony. Is that how you say it?
Yeah.
Yeah. Throughout the summer, or figure out how to make that happen. And if we wanted to do something in the fall.
Well, I would say, yeah, I would like to know how many people are interested. And I would just say right off the bat, the easiest thing to do is just get iNaturalist on your phone and start taking pictures of flowers. And once you've done that, you can always set the property boundaries later because it'll harvest all the data that you have. So just start as soon as things start to bloom, just start. And then you'll get to learn your plants too, because it kind of guesses. It's got a great. Oh, good. Shannon's interested.
Awesome.
But I do vow, if you do this, then we can come together in the fall. We can look at all your farms and we can go through and, you know, start to, I'll learn a lot because I'll learn about your farms, but we can also just sort of figure out where things, you know, what comes out of the program and what's feasible, and, you know, questions, you know, like Lauren brought up, is like, is the plant even available? Is it so expensive that it doesn't make any sense? What are the substitutes?
I'll be following up with resources and information and probably a survey, and ask folks to indicate interest if that's something that they want to stay either a part of or just for me to check in on. So yeah, we can do that.
Okay, fantastic. Well, I'll type my email in the chat if you want to get a hold of me. That's how you do it. And I really enjoyed talking with you. I wish I'd love to visit your farms. That's at all possible.
Yeah, I'd love to have a time to get you out here and do this kind of inventory or something in person too.
And I'll put my phone number too. So if you.
And I can also share this afterwards too. So
great.
You aren't able to catch it. Cool.
Okay, well, thank you, everybody.
Thanks, guys.
Thanks, guys.
We'll see you later. Thanks. I'll send you an email.
Okay, thanks, Andrea. Bye-bye.